Okay, question 19, then circle C1 is defined as x squared plus y squared equals 25. Okay, so a circle, in the origin with radius 5. A second circle C2 has radius 4 and center AB, where A and B take certain ranges of values. If the center of C2 is equally likely to be located anywhere within a given range, okay, what is the probability that C2 intersects C1? Okay, so again, first of all, you need a diagram to see what's happening, right? I mean, I can't see what's happening without a diagram at all. So, diagram. Okay, so radius is 5, so maybe 5 is here, I don't know. Okay, so where could the center be? Well, let's start with, for example, if the center is bang on the origin, when A is 0 and B is 0. Okay, so then your circle C2 only has radius 4, so it will be somewhere here. Right. Okay, so clearly that doesn't intersect, the C1. Yeah. Okay, so how can I make it intersect the C1? Well, for example, what if my center was up here when y is 1? Then you'll be tangential to the C1. Yeah, tangential counts as intersection, of course. Yeah. Okay, so therefore I know that if I go one up, one to the left, one to the right, or one down, then I'll touch it. Yeah. Well, at least one, I suppose. Yeah. Okay. So, and actually that is applicable to all the directions, not only going up, down, left, or right, right? The intuitive directions will be those 4, but you can also go something like diagonally with length 1. Yeah. If your center is here, then you would also be tangential to the circle at this point, right? If you extend this sort of vector-looking line, you will be tangential to the outer circle. Yeah. Okay. So therefore, then you can conclude, right, that if your center lies within the unit circle here, right, if your center lies within the unit circle there, then you're not going to intersect with C1, right? You're going to be at least 1 away from the origin, right? Okay, so we need the probability, right? So if we're talking about a point landing on a certain area, then the probability is just the ratio of the areas, right? So the unit circle is what I don't want. Yeah, what I want is anything outside the unit circle. But now my domain is this sort of rectangle looking thingy. Yeah, it is this massive rectangle from -2 to 2 and then -3 to 3. Right? It's a rectangle if you think in the Cartesian plane. What's the area of this rectangle? The area is, well, the width times the height. Yeah? So this will be 4, the width, and this is 6. Right? So 4 times 6 gives me 24. So 24 is the area of the rectangle. Now I got to subtract the bit I don't want, which is the unit circle in between. The unit circle has an area pi1 squared, which is pi. Yeah. So the area that I want the center to be in is 24 minus pi. This is when the intersection will happen over the total, right? The side over total is always how you calculate probability. So divide by 24, which is the whole domain, which is the rectangle. So therefore you have answer F.